Saskatoon, Saskatchewan. Welcome to Do We Need Biotechnology to Feed 9 Billion People? A public forum and civilized debate at the first Emerging Technologies for Global Food Security Conference. Now, please welcome the President and CEO of Innovation Saskatchewan, Jerome Konecsni.
So Innovation Saskatchewan is the provincial government's agency responsible for the innovation agenda and strategy for the province. And we believe, and we start by defining innovation as turning knowledge into value. Now that value can be social, economic, or environmental. But in our eyes, innovation must result in value. Social license and public acceptance should be an integral part of integrating scientific developments into our lives. But unfortunately, the public discourse has often regressed to the level of schoolyard name-calling. Today, the organizers of this summit have attempted to raise the bar. This event is structured to facilitate open, intelligent, rational, evidence-based dialogue. And I think the organizers need to be congratulated. Morris, you and your team need to be congratulated for taking an innovative approach to moving us down the path of rational and dignified debate. So one of the things you're going to see on the screen coming up here is the actual proposition that our teams, our panelists, will be debating. And that proposition is simply this: GM crops and advanced biotechnology are required to meet the challenges of global food security for 9 billion people. Give you a little bit of context. The primary assumptions here are that by the year 2050, the world will have 9.6 billion inhabitants, and that there will need to be a 50 to 70% increase in food production in order to sustain that population base. And it will have to be done on the same or even less land, and also complicated by varying climate. With that, let me introduce our distinguished panelists for today. Our first panelist is Mark Lynas. Mark is a well-known environmentalist and author of, among other titles, High Tide, News from a Warming World, 6 Degrees, Our Future on a Hotter Planet, and the God Species. Mark is a British environmentalist and author who helped found the movement against genetically modified, or GMOs, in the mid-1990s. But in early 2013, he publicly denounced his past position during a now infamous speech at the Oxford Farming Conference. According to Mark, the tipping point came after he wrote the final anti-GMO piece for the UK's Guardian newspaper, when he realized that he didn't believe the arguments he was making. Mark is on the board of the UK campaign group Sense About Science, and though still resident in Oxford, is currently visiting fellow at Cornell Alliance for Science, based at Cornell University, and funded by the Bill and Melinda Gates Foundation. He has written extensively in world media on the GMO issue, and as well as climate change and science and society. Our next panelist, Jennifer Thomson. Jennifer is Emeritus Professor in the Department of Molecular and Cell Biology at the University of Cape Town. She was Associate Professor at the University of the Witwatersrand and Director of the Laboratory for Molecular and Cell Biology for the CSIR before becoming head of the Department of Microbiology at Cape Town. Jennifer won the L'Oreal UNESCO Prize for Women in Science for Africa in 2004 and has an honorary doctorate from the Sorbonne University. Her research priority is the development of genetically modified maize, which is resistant to African endemic maize streak virus and tolerant to drought. She has published 3 books on genetically modified organisms: Genes for Africa, Seeds for the Future, and Food for Africa. She is a member of the board of the African Agricultural Technology Foundation, based in Nairobi, and vice chair of ISAAA. She serves on the National Advisory Council of the Innovation of South African Minister for Science and Technology, and chairs the South African chapter of the Organization of Women in Science for the Developing World. Our next panelist is Barbara Burlingame. Barbara Burlingame is a professor at Massey University in New Zealand, with a joint appointment in the faculties of Public Health and Food Science Nutrition. In addition, she is adjunct professor of nutrition at Deakin University in Australia and of food studies at the American University of Rome. Professor Burlingame is a scientific advisor, board member of several foundations and academies, specialty chief editor of Frontiers in Nutrition and Environmental Sustainability, and member of the panel on dietetic products, nutrition and allergies of the European Food Safety Authority. In 2014, she retired as deputy director of the nutrition division at the Food and Agriculture Organization of the United Nations, which she had joined in 1998. Prior to joining FAO, Dr. Burlingame spent 11 years as nutrition program leader of the New Zealand Institute for Crop and Food Research. Her expertise and long list of publications includes food composition, human nutrient requirements, biodiversity for food and nutrition, sustainable diets, and sustainable food systems. Her qualifications include undergraduate degrees in nutrition science and environmental toxicology from the University of California, UC Davis, and a PhD from Massey University. She is a qualified sommelier, this is the part I like, and member of the Institute of Wine and Spirits. And our final panelist is a longtime associate, Peter Langridge. Peter chaired a strategic study of biotechnology research in CIGAR and also chaired an expert panel for the Australian government on Australia food security in a changing world. He currently chairs the steering committee for the Dryland Cereals Research Program of the CIGAR and the Science Board of the International Wheat Initiative. He also serves on the scientific advisory boards for several research organizations in Europe and North America, and has often visited Saskatchewan on numerous of these advisory and peer review panel processes that he's participated, so he's well known to the Saskatchewan community. Until 1914, he was the chief executive officer of the Australian Centre for Plant Functional Genomics, and he previously helped develop and manage crop improvement. He served from 1994 to 2007 on the Australian Gene Technology Regulatory Committees and is an honorary fellow of the Food Standards Australia and New Zealand, providing advice on the impact of new breeding technologies on food safety. So this panel is going to be moderated by one of Canada's most prominent and respected journalists. It is now my pleasure to introduce the moderator for our IQ2 debate, Rex Murphy. If you don't know Rex Murphy, then you probably haven't seen a television, you don't have a computer, or you don't read the newspaper. He is one of Canada's most well-known and respected journalists. We are treated to a regular commentary on CBC's The National, as well as his column in the National Post. For over 20 years, Rex hosted the CBC Radio's Cross-Country Checkup. This experience probably contributed to his keen understanding and appreciation of Canada and what it means to be a Canadian. His commentaries are always insightful, poignant, and thought-provoking. While I personally may have kissed the Blarney Stone 4 times, I would never dream of challenging his verbal skills, sharp wit, or fast verbal retort. Besides, I know better. I'm married to a Murphy. Before I ask Rex to come up on stage and assume the role of moderator, I have a message to read from our Premier, Brad Wall. And this is a quote from the Premier. Last night, a few of us Ryder fans had the unqualified pleasure of dinner with Rex Murphy. Ironically, he had to leave early to catch a plane to Saskatoon to be with you all today. I just want to offer that Rex is not only one of Canada's foremost raconteurs, but a great intellect and defender of both the common sense and the common good of our country. I, for one, am grateful for his undeterred support of the economic interests of our province and Western Canada. Sincerely, Brad Wall. Rex?
Good afternoon. First of all, welcome to the debate. I think it's incumbent upon me to release the Premier of Saskatchewan from any impression that he may have given you that he's lost his mind. I think last night that the bottle was stronger than the food. It's the only way he could extort such language out of the Premier as was just delivered by Jerome here, is either under duress or heavy intoxication. I want to say thank you very much for being here. It is quite a treat. It's also very intimidating, as was mentioned, and I suppose it's some part known that for a long while I worked at CBC Radio doing cross-country checkup. But this is much more intimidating because, you know, as opposed to CBC, I'm not used to having audiences. Worked on television too, and I'm not used to having intelligent ones, but we won't go there. Also, just before I get into anything that even bends towards relevance, I'd like to say that I was down in Newfoundland last week, and Newfoundland, as opposed to Saskatchewan, is not a fertile province. So it's a pleasure to be in a place where things actually grow. We tried it back home at one point. Did you ever hear about our great cucumber experiment? Yeah, it's true. We tried to grow cucumbers out of solid rock, ignoring the ancient laws of agriculture that before you really get into anything of growth, you need both soil and light. And of course, in Newfoundland, those only occur when someone from Toronto visits. Didn't mean a word of that. I'm not going to dawdle too much. I was asked to remind people, it's not on the screen, I'm on the screen, that's a horrible thing. If you haven't voted as yet, I have it here, it's okay. The website is Respond.cc, and if you want to register your vote before the moment goes, I'm under orders here from the boss of the entire session. Respond.cc is the website, in-person session key 684550. And the online session key 157950, and if anybody wants a cab, I have a number for that as well. Yeah, I was in Newfoundland, and it's a bit of an experience when you go down there. My brother, even stranger than I am, he went back to Newfoundland after working some time on the mainland, and he landed himself in the most extravagantly and ludicrously named town in the entire island. It's called Sunnyside. And he's going to die of a broken heart. And then I come up here last night, and I thought that I was heading for Saskatchewan, but obviously it's Tahiti. How do you people do it without grass skirts? Anyway, I'll get to the actual debate at this point. It is a topic of great intensity. It's also a topic of tremendous reach. It's at the intersection of poverty and famine, population, science and its handmaiden technology. It's a debate that has certain furies behind it in the contest of philosophies about how we react to or deal or treat with nature. It has so many dimensions that it requires minds, I think, and I'm serious, of some considerable high order to do justice to the various currents that can be introduced into the debate. And that's why, if there are any stars in this particular occasion, it's this particular panel that has been good enough to bring their superlative gifts to a frank, open, extended, and ordered exchange on what is understood to be an extremely contentious topic. I was reading, by the way, and this is true, I don't normally, I read their bios a couple of times, and then I read them again this morning. It's very depressing. I realize I'm useless, and I have no life. These people are at the very, the white-hot tip of all technology, sciences, and as I said, the blend of philosophy and all of these things. And I'm a journalist, not even a good one then, My association with journalism is essentially that of a streetwalker to the Department of Highways. It's where I click my heels. But to revert again to something sane, this is a panel that's equipped to deal with a topic that is as rich and ripe, both with significance and contention. And if there is a way to unfold or to ramify the various issues that are contained within the proposition that we're dealing with, I'll reiterate, the GM crops and advanced biotechnology are required to meet the challenges of global food security for 9 billion people. It is this panel. And the other thing that's noteworthy about it is if you study the flight plans of these people to get to Saskatoon, some of them came even further away than Newfoundland. But really, they've traveled for many, many, many hours to present digested and compressed wisdom on a very, 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 very interesting and solid topic. So if I've got the order of speakers right, I'm about to open the debate. I should mention, just to kind of keep it going, that after each side, it'll be alternating, starting with the affirmative, the negative, the affirmative, the negative. After each side has a breathing room of 10 minutes to present their perspective on the particular question, we will alternate. Then at the end of those presentations, we will open to both the audience and to the internet. We will accept questions via Twitter, and we will have a period 30 to 40 minutes, depending on how things are going, in which the audience can either comment to, place questions towards one or more members of the panel, and in that way extend the debate beyond the stage to the group that's here and the group that's watching online. Following that, again, according to the structured debate that we've set up here today, one speaker from each side will have a chance either to recapitulate the strongest points that they really, really wish to make, or rebut the extravagant follies of the people who opposed what they said. With that, there's no need to go any further. I'm going to ask the first speaker in support of the proposition, GM crops and advanced biotechnology are required to meet the challenges of global food security for 9 billion people, and I will call upon Jennifer Thomson to take it. Jennifer, after you.
Thank you. Planting genetically modified crops is not tantamount to waving a magic wand and suddenly feeding 9+ billion people tomorrow. In fact, if I were to choose a magic wand, my magic wand would be educating women. If we educate mothers, we'll go a long way to feeding families. But I'm here to talk about GM crops, and I come from South Africa, where we plant about 80 to 90% of our maize is GM. It's both insect resistant, BT, and it's herbicide tolerant, and it's both white for human consumption and yellow for animal consumption. It is planted both by commercial farmers and by smallholder farmers. In fact, the smallholder farmers call it Thesa, which means it fills our stomachs. It's been shown to increase yields by twofold, but it varies, obviously, from place to place, but it does increase profits. Now, South Africa is quite unique. There's no such thing as quite unique. South Africa is unique in that smallholder farmers plant GM crops that they eat 3 times a day. Nowhere else in the world does that happen. And so South Africans have been doing this since about the 2005, 2006. And fairly recently, a colleague of mine from the University of Pretoria has published a paper on gender disaggregated data on some of these smallholder farmers. Now, gender disaggregated data is very close to my heart. As Rex said, I chair the South African chapter of the Organization of Women in Science in the Developing World, and I was recently elected as international president. So one of my aims is obviously educating mothers and women, but I'm also interested in gender disaggregated data. But why? Because women in Africa plant crops that feed people. Men in Africa plant crops that make money. Quite a difference. Women who were interviewed in this study, they looked upon the herbicide tolerance as so important for labor saving. You know, so many of our men are leaving the rural areas and going to cities all over Africa. So who does the work? The women and the children. And so for weeding, it's a huge advantage not to have to do it as much as they used to, and also the no-till agriculture that was spoken about earlier today. With insect-resistant BT, it's also labor-saving because in Africa, water doesn't always come out of taps. So who fetches the water? It's the women and the children. And the women say now they have more time to plant vegetable gardens and do other things around the house. Interestingly enough, they also commented on the taste and quality of the GM maize. But one of the big problems they all, men and women, identified was the lack of seed. And we found this. I work for I'm on the board of the emeritus member of the board of the African Agricultural Technology Foundation. And we transfer intellectual property from multinationals to Africans for farmers and seed companies. But one of our big problems is multiplying the seeds. So if any of you are interested in seed production, we need that in Africa. Recently, a study was done at Purdue University looking at the impact of removing GM crops from the surface of the earth. What if we were suddenly to say, okay, no more GM crops? We would then have to, they estimate, bring in new land for cultivation around about 1 million hectares. You can debate the numbers, but that's roughly because of the increase in yield and other attributes. So where would that land come from? We would have to cut down the forests, we'd have to hoe up the pastures, and all that involves the increase in greenhouse gases. So the anti-GMO lobby that would like to dispense with GM crops would also like to decrease greenhouse gases. You can't have it both ways. Food safety also mentioned in this Purdue study, and I am quoting them when they say, it is only the uninformed who would think that genetically modified crops have a food safety question. There are over 2,000 studies that show positive safety in, or should I say, that GM food is no more harmful to us than normal food or food derived from non-genetically modified crops. And may I just say that nowhere in the history of humankind has food been tested as if it were a toxin other than GM crops. Food derived from GM crops is tested as a toxin, like polyurethane or something like that. Now, can I give you a word about my own experience and the problems of the regulatory protocol that we have to go through? As the introduction said, I work in maize streak virus resistance. That's a killer virus that's only found in Africa. We developed GM varieties that are resistant in the glasshouse, but our small seed company, Panelists, that doesn't have many resources, said, I'm sorry. They said to us, we're sorry, it's going to have to stay in the lab because we don't have the resources, the financial resources, to pay out millions of US dollars equivalent to do the feeding trials, the animal feeding trials, to show that this extra protein doesn't give you cancer or cause any other damages, or the multiple types of field trials we have to do. So our maize streak virus, which can decimate a crop in Africa, is sitting in our greenhouse, in our glass houses, and in our fridges, in my lab, and in our Panelists seeds. Fortunately, the other field I work in is drought tolerance. And unfortunately, that has a more wider appeal. In Africa, we are suffering, in South Africa, for instance, we are having the worst drought we've had almost in recorded memory. And many other parts of Africa are suffering terrible drought problems. So recently, our South African government saw the light, and they've given us 10 million to take our drought-tolerant constructs, put them into varieties of maize and test those to see whether they do work. I don't know that it's going to work, but at least we should have the chance. I always say, give people the chance, give farmers the opportunity to test these crops. If they don't work, it's no problem. Nobody's forcing them to buy them, but at least give them the opportunity. But indeed, we have patented our genetic construct. We haven't patented the seeds, but we've patented the genetic construct in order to stop other scientists or other multinationals stealing our ideas, because we've taken genes from an indigenous resurrection plant that can dehydrate to almost 5% relative water content and stay there for months on end, and then add water, and in 72 hours, it resurrects. It's a miracle plant. And we've taken genes from this plant, put them into maize, and hopefully this time next year I'll be able to give you more information. But why are there such stringent regulations on GM crops? After all, scientists for years have been mutating crops. There are something like over 2,000 varieties from wheat to grapefruit that have been bombarded with mutations, either radiation or chemicals. What do they do to the rest of the genome? Could they cause us now to suddenly grow green horns or something like that the anti-GMO movement said GM crops would do to you? Or more seriously, as I was told when I addressed the United Nations, they will make humans sterile. If you eat this, you will become sterile. Tell that to any African man and they will think twice about that. But what are mutations doing? Nobody knows, because we just accept them and nobody regulates them. However, and this is my final point, there are almost no GM crops elsewhere in Africa, apart from South Africa, Sudan, and Burkina Faso. Why? Because Europe's attitude influences Africa. Africa gets almost 6 times more of its aid from Europe than it does from America and Canada. If the Europeans say GM crops are bad for you, if the Europeans come to Africa and say eating GM crops will make you as a male sterile, what effect is that going to have? But I don't understand the logic of the Europeans, because they happily import GM soybeans and maize from Brazil, Argentina, America, where it is almost 90, almost 100% in some cases GM. They'll happily import it, but they won't allow their own farmers to plant it. Can somebody explain the logic? So, it would be, I think, a great shame if well-fed Westerners, and I'm not talking so much about the Canadians and the Americans, but there are Europeans in the audience, if well-fed Westerners use their prejudices to prevent hungry Africans from benefiting from this technology. It's not a magic bullet, it's not a magic wand, but it can help to feed 9.6 billion people. Thank you very much. Thanks.
We're off again. I'm used to that, especially where I work. This lady is a panelist delight. I'm not taking sides in the debate, but she has a better sense of timing than the clock they use to send off rockets to various planets. She came in dead on the 10-minute mark. I'm going to introduce now our next. This is the first statement by an opposition to the resolution. And Peter, if you're ready, Peter Langridge, I invite you, sir, to the podium.
Thank you, Rex. I need to first apologise for wearing an eye patch, but I'm doing it for 2 reasons. One is there are bright lights there and I've lost the iris of my right eye. And the other reason is I'm hoping to capture the sympathy vote here. So far I'm not convinced there is much of a sympathy vote out there, but no, I need to put my glasses on. I've got my glasses on. So I can't, so even with my good eye I don't see all that well, you can see. I think I probably should start by reiterating the question, because I have a bit of a feeling that the proponents of this proposition haven't really thought about what the question is. It is GM crops and advanced biotechnology are required, I put the emphasis on required, to meet the challenge of global food security for 9 billion people. So I think the question we need to ask here is it required? What are the alternatives? What other things can we do? And what is the potential impact of GM crops? We heard from the study which claimed that there would be a huge area of land that would be required if we removed GM crops from the current production system. But that study didn't include considerations of what new technologies might be able to do and how they may be able to have an impact. I think we first need to try and look at and identify the factors that are limiting production and the factors that we can address, where there are interventions we can use to try and improve the current levels of production. For those of you who are at the talks we just heard before we came here, I must admit when I was sitting there listening to those talks, I was thinking, well, basically the case has been made for the opposition. Maybe I don't need to say anything. I can just sit down there and listen to the comments. There are very many things we can do. There are very many opportunities for how we can try and tackle the problems that currently face our production systems, our production environment. I think broadly speaking, we can put those interventions into two classes. One are addressing the biophysical constraints of production, and the other are addressing the socioeconomic constraints. Clearly, in the biophysical constraints, there are issues related to climate, the unpredictability of rainfall, the problems associated with water availability, particularly if we look at the issues that are going to be faced in India and China over the next decade or so with declining water availability, the impact that that will have on production in those regions is enormous. Rising temperatures are also going to put pressure on water availability. We have problems of salinisation, we have problems of acidification. A lot of these are related to poor management practices and poor irrigation systems. We know they can be addressed. We know they can be addressed by managing the use of water more efficiently, by modifying the way in which we use irrigation water during our production. Then we have all of the issues related to soil fertility. Again, we heard a talk earlier on about the importance of the impact of fertilisers. We know that in many parts of the world, fertilisers are not available. They're not easily accessible. We have problems of low and declining fertility generally. We have problems of farmers having access to soil testing to simply know what it is that they need to do, what fertilisers they need to apply, let alone the question about whether they have the resources and the finances to buy the necessary fertilisers. Problems associated with micronutrients, micronutrient supply. Again, very simple interventions to try and address these problems, but they have a huge impact upon production systems. Issues related to organic matter within the soil. In many production environments, and particularly in many poor and dry land production systems, farmers need to use all of the organic matter from their crop either as fuel or for animal feed. Can we address that? Can we make more efficient use of the biomass that's available? Then we have the problems related to pests and diseases. Yes, there are possible GM interventions we can do there, but there are many, many other ways of managing pests and diseases, using crop rotations, clearly using chemical sprays to try and control those pests. There are many things that can be done to try and tackle that. Weeds, herbicides, availability of herbicides can be very important. Certainly having GM crops that are herbicide tolerant helps in that process, but there are many other ways in which weeds and wheat can be managed. And then finally, we have the question of the availability of seeds and new varieties to farmers. We've already heard from Jennifer that this is possibly one of the biggest limitations to the adoption of GM or indeed any other varieties in many of these production environments and systems. Okay, so that's just the biophysical constraints. Lots of things we can do there, lots of things that would have a really big impact. Then we go to the socioeconomic constraints, problems related to the changing way in which farms are managed. We're seeing increasingly all over the world, both in the developed and developing world, small farms getting smaller and uneconomic, large farms getting bigger and are driving out some of the smaller producers. There are problems about access to seeds that I've already mentioned and fertilisers, whether the finances are available for farmers to be able to get the materials that they need. Farm machinery is a major limitation in many parts of the world. For the large machinery companies, making small plot harvesters and seeders is not economic, but this could have a big impact upon the way in which the farmers operate and help address some of the labour problems that we also heard as being a significant constraint in many of these regions. And then all of the issues related to how the crop is handled and processed and managed. Do farmers have access to good storage facilities? If they can store the grain, they can sell it at higher prices when the prices spike. Otherwise, they need to try and get rid of it very quickly. Transport becomes a big impact in these things. Again, this is not rocket science. This is not high technology to try and deal with these things. And I think that's part of the problem. We as scientists, we always try to look for the scientifically exciting, challenging approaches and strategies. Probably what I've just said to you has bored you, witless, to some extent. That's part of the problem. Those simple solutions, those simple interventions are boring. They're not exciting. We know what to do. There have been plenty of examples of how they can be implemented, and they can have a huge impact. So this doesn't mean that GM is completely useless. It has lots of things that it can do. One is it keeps molecular biologists occupied. Who knows what damage they might be doing if they are out there in the broader community. And it also, on the more serious side, that in case you didn't realize that was a flippant comment, on the more serious side, it does teach us quite a lot about the biology of the systems. It does improve our understanding and our knowledge about how we can deploy technologies. And I suppose this is I think the next point that we really need to consider. As our understanding of genes, the way organisms operate and the way they function, there are many other ways in which we can go about deploying that knowledge and technology apart from developing GM crops or using genome editing or whatever the new technologies might be. If we take all of those various things I talked about together, there are many parts of the world where we can have an enormous impact. I work quite a lot with colleagues in Kazakhstan, really trying to look at the way in which they go about breeding wheat, barley, and chickpeas in that country. For wheat, currently the wheat yields in Kazakhstan are less than 1 tonne per hectare. If they had access to reasonable varieties, proper machinery, proper management practices, proper breeding programs, so they were systematic in the way in which they did their breeding, had access to biometric tools so they could actually do proper field trials and get proper validation, the impact on production would improve dramatically. It's been estimated that they could go from less than 1 tonne to over 3 tonnes per hectare in that environment. And these are enormous gains. These are not gains that a new gene for drought tolerance might give you a 5% yield benefit. These are gains that we're going in hundreds of percent improvement, and that's simply by applying existing technologies that we already know a lot about. Even within the breeding sphere, there are new technologies, there are new approaches, new ways in which we can utilize our knowledge of the genetics and the makeup of the organisms, ways in which we can go about selecting for large numbers of genes with small genetic effect, technology referred to as genomic selection, which has been so successful initially in dairy cattle, but is now being increasingly applied to crop breeding. The utilization of fairly simple analytical tools. I mentioned already biometrics. The advances that we're seeing in statistical techniques for evaluating how crops are performing has had an enormous impact. You need to think about it. The highest yields that have been achieved anywhere in the world for wheat are over 15 tonnes per hectare. The average global yield for wheat in a non-irrigated system is about 1.5 tonnes per hectare. That means under most production environments, 90% of the yield is lost, mainly due to water availability. But a breeder is actually working with that 10% genetic component in their analysis. So the ways in which we go about improving the rates of genetic gain in breeding programs is enormously impacted by the ways in which we design our field trials, evaluate our crops. In very few parts of the world are those technologies being applied. In order to have them applied, we need breeders who are trained, who know how to manage a breeding program, who have the skills and the knowledge to use statistical tools and techniques. I saw a survey a few years ago about cassava breeders. I think they identified only 5 cassava breeders in the world. This is a major subsistence crop, and there are no breeders out there. There's no investment in the breeding. There are no resources to the farmers to be able to manage that crop. Just think of the impact you could have by using modern technologies in a crop like that, and the way in which you could achieve quite dramatic improvements.
Peter, 1 minute.
Okay. I said I wasn't going to be rude about GM technology, and by and large I haven't been rude about gene technology. One of the problems, and I think one of the most significant issues we have to deal with, is that we know that we can make significant gains by investing, by providing funding and resources, for example, training breeders, supporting breeding programs, having larger breeding programs. We are spending a huge amount of money at the moment on biotechnology, on generating GM crops. If that investment was gone into other areas, just think of the impact that might have. There's also a naivety that we see in many regions. As I said, there's an excitement by scientists in using and deploying new technologies. That excitement is also partly this belief that somehow it is a magic bullet. It's easy to say that it isn't a magic bullet, but if you go to many of the researchers in developing countries, they do see it as a magic bullet. They want the latest technology, they want the latest toys, and they are basically diverting resources that could be more effectively used in these other approaches to that type of strategy. So, is GM and advanced technologies, are they required for global food security? I think they might possibly help. They might account for 2/5 of 5/8 of a very small amount of the improvement. But shouldn't we be focusing on the technologies that we know will have a big impact? Shouldn't we be making sure that those are being properly developed and deployed before we start talking about some of these other approaches? Thank you.
Very good.
I'm just thinking about maybe there's a combination here. If I could get the eye patch and if someone would loan me a cane, we could have something going here.
You're on.
That's a good thing. I'll now call upon our third speaker, Mark Lynas. Mark, please.
Thank you very much, and it's been a pleasure traveling the 12 hours required to be here with you in Saskatoon. I came all the way from sunny England, Oxford in fact, and in fact the rules for this process, this IQ squared, it says it's the Oxford rules, right? So if we lose, then I'm going to have some explaining to do back home in Oxford. So please bear that in mind when you're voting. Right, that's my sympathy vote pitch, absolutely. I can't do the eye patch, but there we are. Now, the proposition is that GM crops and advanced biotechnology is required as part of the toolbox that we need to feed the world's population of 9.5 billion by 2050. And it's interesting that the other side hasn't yet made the case that they're not required. Peter just said very eloquently and with a good degree of passion that many other things are required as well. And that's a case that Jennifer made. So you pretty much could be appropriated for our side of the debate. Unless you come here and say that GM crops and advanced biotechnology are not required and you can exclude them from the toolbox, then I think you can consider yourselves on our side of the debate. Because you said it's not you said that it's not a silver bullet, and yet once again I agree with that. Other things that have to happen in order to feed the growing world's population. We have to stabilize the climate. We have to see significant advances to reduce greenhouse gases. Otherwise, it's going to be increasingly difficult to produce crops on a majority of the world's farmland, which is going to be affected by rising temperatures and spreading droughts. We have to also make much greater progress towards eradicating extreme poverty. People who die in famines or who suffer from malnutrition aren't in that situation because they haven't grown enough GM crops. It's a fact of poverty. We have to address poverty. That's why people in Australia don't die when there's a drought, and people in parts of sub-Saharan Africa may well face that situation. We also need demand-side changes. One thing that hasn't been mentioned yet is about meat consumption, particularly from ruminants, particularly beef. We're going to have to do what we can to increase healthy eating patterns around the world, particularly as developing countries adopt more meat-based diets. That's going to really increase the demand on world food in general. And I do have one problem with the way the proposition is worded. This whole thing about feeding the world's population has been a kind of an industry talking point for far too long. I remember when GM crops were first introduced by Monsanto into Europe in 1996, and they came in with an ad campaign saying, this is a tool to feed the world, and we all knew that it was about them selling their soybean into European markets. So I really think we need to reappropriate the food security argument back to where it really counts and not have it as a tool for industry PR. And it's particularly galling to hear this when we know how much of the world's crop production is wasted. How much of the US corn production goes into being burnt in cars for biofuels? How much of it goes into high fructose corn syrup, into Coke to make people fat? How much of it's wasted in other parts of the production chain? So how can they come here and say that we need to increase this kind of production to feed the world's population when so much is already being wasted unnecessarily? Now, my change of mind on this issue from being a GM crop vandal, and I actually personally physically destroyed and cut down maize crops, and sugar beet, and oilseed rape, and a variety of other things when it was too dark to be quite sure what they were. Sorry. There's one or two people in this room whose research I set back by a year or two, so once again I apologize for that. But my change of mind didn't come from simply evaluating directly the science of biotechnology. It came really obliquely through looking at the climate change issue and realizing that the scientific perspective was missing from this debate. And really it's the same for GM crops. The scientific perspective is missing. The scientists have failed to do the job that they need to do to communicate to the population as a whole, which is very suspicious, even superstitious about biotech crops, that the debate, at least on safety, is over. And I noticed that, that the opponents of this proposition haven't made a case against the safety of GMOs and probably won't, because there is no significant debate about that within the scientific community. You saw that re-emphasized again last week with the National Academy of Sciences report. So, I would say if you vaccinate your kids and if you believe in global warming, then you really mustn't be concerned about the safety of GMOs. And that's a really important point, I think, to make to the population as a whole. So why would I argue that, and why would we argue that GMOs and advanced biotechnology are an important part of the toolbox, as well as all the other things that scientists need? Well, because using GM, you can have access to a much wider germplasm of genes that may be of interest to accomplish particular things. With us in the audience today is Lina Tripathi from Uganda, who has been developing bananas resistant to bacterial wilt, which is a really serious challenge to the staple food supply in Uganda and elsewhere in East Africa. And where do these genes come from? They're the HRAP and the PFLP genes. They come from sweet pepper. Now, you can't do that with conventional breeding. So that's simply an option which is not available if you take that off the table. There's also virus-resistant cassava under development. Where do the genes for that come from? They come from the virus itself. Now, you can't accomplish that using crossbreeding. And that's a technology which has been incredibly successful in Hawaii and has saved the Hawaiian family farmers from the virus which was going to devastate their industry back in the 1990s, in papaya, that is. You can also speed up crop breeding. So in potato, for example, very difficult to breed potatoes conventionally. It takes a very long time. You get a lot of yield drag and other problems. I've personally cultivated blight-resistant potatoes which have been bred conventionally. They taste like, and it would be a lot better if just the genes which confer the blight resistance could be taken into potato varieties that don't taste like. And to do that, you need to use genetic modification. Now, for advanced biotechnologies, we're looking at CRISPR, we're looking at other gene editing technologies. I can't for the life of me understand why these are considered somehow diabolically GMO, just to edit or knock out a single gene, when we've been blasting apart the genomes of entire crops using chemical and radiation mutagenesis, and that just goes straight onto the market and even appears under a price premium with an organic label. So there's no logic at all to this debate. And I'm not saying that we shouldn't use chemical mutagenesis. It's probably an older technology, but it's part of the toolbox. So let's use what is appropriate at the time. So I would like to hear any arguments from the other side that GMO crops or that GMO techniques or advanced biotechnology should be banned. Maybe you won't make that case, but that is the situation that we are in Europe. That is the situation we are in most of Africa. That is the situation we are in large areas of South Asia. Now, this cannot be sustained, and we cannot feed the world's population, and we cannot do so sustainably if we go around banning entire classes of science and technology because of superstition and widespread misinformation. And that misinformation has been a serious, serious problem. In Uganda again, ActionAid, the charity, has been running radio adverts saying that GMOs will cause cancer, funded, of course, from all of the people who want to donate to help solve poverty from European sources. Why is this misinformation being allowed to be spread? The European Parliament only last week voted by 577 to 24 to deny GMO crops to African farmers. Why are we seeing a situation where European politicians decide what is and what is not appropriate for Africa? There's a word for this. That word is neocolonialism.
Yes.
In Bangladesh, where I've been 4 or 5 times now, the anti-GMO campaigners go around to every single farmer that's growing BT eggplant, and they say to them, this will cause paralysis. Your children will be paralyzed if you allow them to eat this crop. And so what's the alternative? Well, the farmers carry on growing conventional brinjal, which is sprayed every 2 days with some of the most toxic insecticides, which are going into the runoff, which are affecting the farmers' health, and which are also affecting their livelihoods because they're so expensive. So why not have GM as one of the options that these farmers can have so that they can dramatically reduce the use of the chemical pesticides? So don't take it from me that GM is a part of the solution, if not a silver bullet. Ask the farmers of Bangladesh. Ask the people of Uganda. And ultimately, we need to let the farmers and the consumers decide themselves what technologies they want to use and not let others dictate to them what they can and can't do. So I urge you to support the motion today. Thank you very much. Thank you.
It's a lot better than checkup, I'll tell you. Now call upon the last speaker, Barbara Burlingame. Barbara, your microphone.
Thank you very much. Fortunately, we don't have to make the case that GM should be banned. We're simply asked to make the case as to whether or not we need GM advanced biotechnology to feed 9 billion people. And first of all, let's strip that down. What does that mean? In its bare essence, it really means we need food security and nutrition for all. The agriculture model of food security is production. Its metric is dietary energy supply, that is kilocalories or kilojoules per person per day. The FAO estimates that there is currently more than enough food produced to feed 9 billion people right now. Yet in our world of only 7 billion, there are about 800 million hungry people. The reasons for that has nothing to do with production. It has to do with lack of access and, among other things, food losses and waste. And it is estimated that about 30% or more of the food produced is uneaten. In places like Africa, it's food loss at the level of agriculture and post-harvest. In developed countries, it's at the level of the consumer. So this part of the issue, global food security, related to food production and dietary energy supply, the answer is no. We don't need GM technology. So if we move to the nutrition part of the issue, we have the World Health Organization estimating that around 2 billion people suffer from micronutrient malnutrition. That would include the 800 million hungry people, plus another 1.2 billion whose numbers are included among the adequately nourished or overnourished, again using dietary energy supply as the metric for nourishment. Biotech has assumed a role here in micronutrient malnutrition. And they've coined the term biofortification. And that is modifying foods to increase micronutrients. This has become a real opportunity for ag biotech to redeem itself in the face of some very bad press over other issues. The two emblematic foods for biofortification are golden rice and orange flesh sweet potatoes, and vitamin A deficiency is the target. One of the most widely measured and thus most widely acknowledged of the micronutrient deficiencies is vitamin A. Vitamin A as preformed vitamin A or the provitamin A carotenoids. It's widely measured because there are a number of easy to analyze and observe biochemical and clinical manifestations of vitamin A deficiency. But vitamin A deficiency never exists in isolation. It's a marker or an indicator for general micronutrient deficiencies or a poor quality diet. To treat a vitamin A deficiency with vitamin A, for example, in the form of a supplement or a biofortified product, is what we in nutrition refer to as the great vitamin A fiasco. To solve the problem of a vitamin A deficiency with golden rice is like treating a broken bone when the person is suffering multiple organ failure. Because it is not just vitamin A, even though that is what we've measured as the deficiency. So diet, and ideally sustainable diet, is the best course of action for treating micronutrient malnutrition. There are hundreds of foods in traditional diets providing a complete package of nutrients, and not just conventional nutrients, but other beneficial bioactive components. Food composition tables from the 1950s, 60s, 70s, the days before GM technologies, list hundreds and hundreds of fruits and vegetables, starchy staples, animal source foods, loaded with more vitamin A and more pro-vitamin A carotenoids than golden rice, and a whole array of other components needed for a healthy life. And make no mistake about that other poster child for biofortification, the orange-fleshed sweet potato. This is not a creation of ag biotech. These orange-fleshed sweet potatoes have existed for millennia, with hundreds of traditional varieties in this vast biodiversity of the species. Food composition tables from several decades ago, for example, the FAO food composition tables for use in Africa and East Asia and Pacific Island countries, published by others, show traditional yellow and orange sweet potato varieties with values of beta-carotene that exceed 5,000 micrograms per 100 grams. This is significant. And continuing on this same micronutrient theme, there are, and I'm glad Mark mentioned bananas, there are banana varieties native to different parts of the world. I'll talk about Pacific Island bananas, with beta-carotene contents in excess of 8,000 micrograms per 100 grams. Compare this to the very fragile Cavendish banana that we all know, with virtually no carotenoids, and we can look to biodiversity for providing these micronutrients. In traditional food systems, there are local green leafy vegetables with pro-vitamin A carotenoid values exceeding 10,000 micrograms per 100 grams, and when these are cooked and served with traditional sauces containing oil and other nutrients, other nutritious ingredients, the carotenoids become highly bioavailable, and therefore they're delivered efficiently to the organism. And in addition, as with foods and diets, there are hundreds of other nutrients and bioactive non-nutrients that are part of that package of foods and diets. Now, through a number of scientific workshops and symposia in recent years, the topic of sustainable diets was addressed. Among the many outcomes of this work on sustainable diets, a consensus definition was reached. Sustainable diets are those diets with low environmental impacts, which contribute to food and nutrition security and to healthy life for present and future generations. Sustainable diets are protective and respectful of biodiversity and ecosystems. They are culturally acceptable, accessible, economically fair and affordable, nutritionally adequate, safe and healthy, while optimizing natural and human resources. In December 2009, on Gorée Island, off the coast of Senegal, at the House of the Slaves, which is a museum and a memorial to the Atlantic slave trade, and in front of that infamous door of no return, Afro-food leaders, Afro-food coordinators, drafted something called the Afro-Foods Call for Action, symbolically renaming it the Door of Return, for a food renaissance in Africa. They noted that the degradation of ecosystems and the loss of food biodiversity was contributing greatly to increases in poverty and malnutrition in Africa, and they recognized that returning to local crops and traditional food systems was a prerequisite for the conservation and sustainable use of biodiversity for food and nutrition, and they acknowledged local foods were the basis for African sustainable diets. So a final word, I have another minute and 38 seconds, about sustainable diets and sustainable food systems. Production intensification causes a lot of collateral damage, including to food security and nutrition. Among these damages would be biodiversity loss and ecosystem degradation. And one example I'd like to cite is a rice-based aquatic ecosystem. In a non-intensive system, communities get most of their micronutrient adequacy from not the rice, but the other aquatic organisms, the hundreds of species of small fish, amphibians, insects, and aquatic plants. Intensifying these systems gives a higher yield of rice, obviously. But that leads to destruction of those other food resources that for the entirety of the history of rice farming have satisfied the nutrient requirements of the populations living there. The International Rice Commission acknowledged this situation and recommended to its members that the existing biodiversity of rice varieties, and there are thousands of rice varieties, and their nutrient composition should be explored before engaging in transgenic modification of rice. Golden rice had already been created. And that member countries should promote the sustainable development of aquatic biodiversity in rice-based ecosystems, and that policy decisions, management measures, et cetera, should enhance the living aquatic resource base. The year 2014 was declared by the United Nations the International Year of Family Farming, crediting the 500 million smallholders around the world with the slogan, "Feeding the world, caring for the earth." The main message was this: family farmers run crop diversification-based agricultural systems and preserve traditional food products, contributing both to a balanced diet and safeguarding the world's agrobiodiversity. In the final analysis, GM is not necessary to feed the world. We have many other means at our disposal for ensuring that food systems are sustainable and that there is food security and nutrition for everyone.
Well, that concludes the first installment of this debate. At this point, and I'll also be dealing with the online notifications, at this point we're inviting people in the audience and people viewing this with different apparati, either by Twitter or some other means that I don't fully understand, to send questions to us, and then we will direct them, as you direct us to direct them, to one or more members of the panel. I should give the Twitter address again, am I correct? I'm taking instructions. Hashtag GIFSCONF2016, and I'll repeat that. It's, I think, next to my Halloween face. Hashtag GIFSCONF2016. You can tell from the range of exposition that you've just received that the contest is indeed on. I'm particularly sympathetic, not because of your stage props, sir, the idea of controlling those molecular biologists. That deeply appeals to me. We can extend it to some other groups that I'm familiar with too. I'll just open, we have a microphone in the audience, and we have one possibly also at the back. So if anybody wishes to initiate the discussion here or make remark, comment, or question to any of the panelists, prepare yourselves and come forth. There's the gentleman there.
Okay, thank you. I would like to say thank you to all the panelists for the good work they've done. My question goes to Barbara. First of all, I'm amazed by the kind of misinformation that we are giving out. I will start by your comments on orange-fleshed sweet potato. I'm wearing orange because 100% of what I do is promoting orange-fleshed sweet potato. I work for the International Potato Center, and specifically on sweet potato seed systems. There is no single point we've ever said that orange fleshed sweet potato is GM. The International Potato Center, together with National Agricultural Research Systems, have developed over 50 varieties of orange fleshed sweet potato in African countries, in different countries. And this is all through conventional breeding. And our work on biotechnology in sweet potato specifically is towards developing varieties which are resistant to weevils, which is one of the major pest problems in sweet potato. So I think actually before giving out some information, it's good to do a background check on that, because when you tell people that OFSP has been promoted as a GM product, is not correct. But I would like to say another thing. You said that you mentioned golden rice. You forgot to mention crops like the African fortified sorghum, which does not specifically address vitamin A, but looks at other micronutrients like zinc. And I know there's so many other projects which are focusing on other micronutrients. So it's really important to get the facts correct before giving out this information. My other question I would like to address is to Peter. Thank you. Peter, you mentioned about the idea of embracing all the technologies. Yeah, biotechnology is not a silver bullet, but it plays an important role. Every day I work with farmers. They are facing pest problems. When you look at cotton farmers, they spray their fields up to 16 times. And when you look at the investment on pesticides vis-a-vis what they are going to get as returns, is actually a negative return.
Okay,
so
bring to a question and I'll go with them.
Okay, I'd like to just stop there, but my point is let's give clear information and...
Okay. Barbara?
Yes. Thank you. You reiterated my point by saying orange flesh sweet potatoes are not a product of GM technology. The very early days of Harvest Plus and others, they were promoting it as a product of not GM, but a product of ag biotech, and subsequently not. But there are people around the world who think it is, and my point was exactly what your point was. It is not
You called it
product.
you called it the poster child of biotechnology, and yet it turns out it was produced by conventional breeding.
I
It's
said,
completely misleading.
no,
So
okay, because it has been promoted as such, and you read a lot of media releases about biofortification, and they link GM golden rice with orange flesh sweet potatoes. And my point is, for millennia, these orange flesh sweet potatoes have existed.
Mark, do you want to expand on what your objection was there?
well, I'm glad actually that Barbara made the point you did, because at least it gave me something to violently disagree with. Unlike most of what Peter said, I agree that molecular biologists need to be controlled properly as well. But, I mean, your arguments against biofortification and saying that these micronutrient deficiencies are issues of poverty, I think, of course, generally that's true, but your argument, your analogy was completely wrong. I mean, you could make the same case against vitamin A supplementation.
I did.
You did. So you're against vitamin A supplementation? They
No.
shouldn't actually be given vitamin A to children who will die as a result of their deficiency.
That is the vitamin A fiasco. You need to cover a whole range of micronutrient problems. It's a diet quality issue, not a single one or two micronutrient issue, even though you're only measuring one or two micronutrients.
I'm not. That doesn't clarify it. Are you for or against programs where they give vitamin A supplements to children in poorer countries so they can survive?
I am for food-based approaches that solve the basic problem of diet quality and solve through food and through proper diets the problem of micronutrient malnutrition.
Okay,
well,
we'll go. Peter, you should get one more because you were directed as well.
Yeah, I think there's a point of clarification we need to make here. So we are not saying that GM crops should be banned or that they're completely useless. That's not been the tenet of our argument. This debate is about whether GM crops are required, whether we could not provide food security if we didn't deploy GM crops. Our argument is that we can provide global food security by a whole range of technologies. That doesn't mean GM crops should be banned or removed, destroyed, mowed down, dynamited, whatever you want to do. As far as we're concerned, they're fine. Leave them there. They're okay, no problem. But they are not absolutely required for global food security. There are a hell of a lot of other things we can and should be doing. That's our argument.
Here's equivocation for you. Next person, please.
Thanks, Rex. I wasn't going to get into this argument with Harvest Plus, but I feel I have to because that whole Harvest Plus program started at the center I direct at Cornell University. It's a food-based approach to addressing micronutrient malnutrition. Most of it uses traditional plant breeding, including the orange flesh sweet potato, but within those quiver of arrows for shooting at targets of global food insecurity, biotech is part of it. We all recognize that micronutrient malnutrition was an outcome of the Green Revolution. We've now greatly lost diversification in diets, so part of it is simply diversifying diets, adding pulses back, which are much higher in iron and zinc, fortifying with zinc, which will get zinc into the seeds, adding a little more meat, etc. But one of the other arrows in the quiver is biotech. When there are traits that we don't have the variation for or can't generate it with mutagenesis, or it is, why give up on that one? So I think, I'll cut off here in a moment, but the way this question was posed, this argument's gotten to be a bit semantics and parsing meanings. I think we all feel we should use every tool we can to address this really very serious problem, and one of those is ag biotech. Does that mean it's required? I think so, but I guess you could also argue it could mean it isn't required.
Okay. Anyone on the panel, before I go to the next question, want to comment on that?
Yes, I would like to comment.
Please.
Because there are genes that are not available that can be bred in. For instance, Linatropathy's bacterial wilt problem. And so without GM crops, you do not have the full spectrum of technology that you have with classical breeding. So I would say we have to have it for certain problems, but I'm not against any of the other problems that any of the other techniques that Peter has proposed.
With one exception, actually. I mean, Peter made the case for chemical pesticides as an alternative to having pest-resistant GM crops, and I just want to re-emphasize that. That's the situation you have in much of the world for cotton, for example. Very chemical intensive in terms of pesticide production. Same for the farmers of Bangladesh. And by the way, Barbara seemed to make the case that it was family farmers or GMOs. It's family farmers using GMOs in order to stop using insecticides. So it's very important to have that spectrum so that we can actually reduce the environmental impact of crops.
Okay, you go ahead.
I suppose a couple of points there.
It's okay.
You know, the argument's been made by the pro group there about the need for the genetic diversity that comes from GM. But I think we also need to remember that in germplasm collections around the world, less than 10% by and large has actually been utilized in breeding programs. There's enormous diversity that we've never even tapped into. And we can see some spectacular examples. If you look in Europe at the moment, one of the dominant wheat varieties and its progeny is Robicus wheat. That came from a cross, a serendipitous cross that someone made with a wild Emma wheat 20 or 30 years ago, and that's led to about a 10 to 15% yield benefit. And there are lots of other examples I can come up with. We haven't really explored fully the genetic diversity that's around there and that could potentially be deployed. And shouldn't we be doing that first? Because we have the technologies to do it.
Okay, I just want to make sure that as many who wish to participate do get in. Persons who are outside this room or in the so-called overflow area, if any of you want to come in and take the mic to ask a question, make a comment, you're absolutely invited to do so.
I just got one very brief question, which seems to be that the people against the motion seem to be relying on technologies which have been around for a long time, 30, 40, 50 years. And so I'm wondering if, given that they have been around for so long, then why haven't they been more successful in having a greater contribution towards increasing world food security? And why deny us the opportunity, and people in developing countries in particular, the opportunity of adding another quiver, another arrow into their quiver of arrows?
You want to direct it to anyone in particular? Or?
I would like to start with
Go
a
right
slight
ahead.
explanation.
Go right ahead.
You made some comments earlier on about Newfoundland. I'd like to point out that Mark comes from Tasmania. And in Australia...
It's going to be a clean fight.
Blood relation. Go ahead. Anybody? Okay, we have a question from Twitter, which always sounds strange when you say it like that. We should, the microphone, can the world reasonably reduce food waste to the point where GM is not needed? In other words, is food waste of such proportions that if it were reduced, that the other aids, the toolbox you've all referred to, would not in itself be necessary, any or all?
GM can help to address food waste. BT genes in corn, for example, can help protect us against some of the toxins that come from fungal infections. So again and again and again, it's like you're saying, oh, we don't need GM. You're hearing you don't need GM because we've got chemical pesticides. We don't need GM because we've got to improve irrigation. We don't need GM because we've got access to conventional germplasm. Well, as part of that system, it's one of the options. So I think you've really got to make a better case for why we should take GM off the table. I haven't heard anything yet which is even vaguely persuasive.
Before you go, what is the absolute central point for the argument that, never mind required for the 9 billion for the moment, that GM is absolutely essential in relation to feeding the world? What's the central core argument that GMO is the essential and necessary as opposed to a part of a range of other alternatives? What's the core?
Well, it's the point that Jennifer just made, that there's things you can do with GM that you can't do using conventional breeding. You can't bring in genes directly that are of interest from other species. So you have access to much wider germplasm to tackle things like disease resistance and so on.
There's another point, because with genetic engineering, you're using a specific set of genes, or even one gene, and that is much easier to breed into many other varieties. So it's a very specific tool.
Particularly for things which don't conventionally breed easily, like banana. So.
What's the core sentence or the core point where you say, we don't want these, or they are not necessary? Either one.
I would simply say they are not essential for allowing the world to feed a population of 9 billion people.
That has been the tenet of our argument. We're not saying that they shouldn't be there. We're simply saying they're not required. And I think returning to Mark's question, which I must admit I was excessively flippant in the response there.
Tasmania is a hard blow.
I think we need to remember that delivery of technologies is actually a very slow and complex process. And I think that's one of the difficulties we have with the GM side of people. They seem to think you come up with your GM crop and suddenly it's accepted and adopted everywhere else. If you look at something like minimum till agriculture, that was first proposed in the 1950s and 1960s. And it's now fairly well implemented in the developed world, but it's still a long way from being effectively implemented in the developing world. And yet the benefits of that are easily demonstrable. So we need to remember that there's a long time lag to see a new technology adopted and implemented.
But no-till has been greatly facilitated by GM crops. So you've just countered your own argument again. I mean, you only have to go outside the room here in Canada to see how the no-till revolution has been facilitated by herbicide tolerance.
Yep.
No,
It's
I would
absolutely
have to
transformed
say
the
that
system.
that is a completely inappropriate response to that question.
We'll get to that one in the rebuttal. We have a gentleman in the audience, sir. Have a go at the panel, and a lady behind you. One at a time.
Jennifer, Mark, why did golden rice not take off? There are a lot of hope on that.
Oh, do you want to? I thought you were going to say two. Golden rice has not been a great success for various reasons. One which I'm particularly keen to emphasize when I'm always hearing that Greenpeace is blamed for blocking golden rice. The important thing to understand is that IRRI has never put golden rice forward for approval. So it's still not been finished by the scientists who are developing it. So I think it's a pretty good example, actually, of how the technology needs to be properly applied. And that's why the silver bullet approach is not correct. You should not wait around for golden rice to be ready. You absolutely have to deal with the other things to improve the food systems that people have access to.
Okay, anybody? You're next, please.
No, actually, it's Grant, I think.
Oh, sorry, I keep getting distracted. Go ahead.
Thanks, Rex. I'm a former politician and an economist and a farmer. And I'm really enjoying the debate, and I congratulate people who put this together. One of the things that you just begin to touch on that I think will help feed the world is how markets work. And in Saskatchewan, for example, if you were to tell Saskatchewan farmers they couldn't grow canola, GMO canola, you would have a big problem because it's made so much money for so many people, and we export it all over the world. So if the European Economic Community or somebody else was to say, well, you can't use GMOs here, I mean, you'd have a riot on your hand. And I think the very fact that they don't allow other people in other parts of the world to make money, to make a really good living for some silly reason that they can't really justify is absurd. And it's a serious economic and political problem. So a good part of feeding the world, in my view, is structuring markets so that people can make money. And it's a huge incentive. Saskatchewan and the Western Canada has been reformed because you can really make cash flow with GMOs. And I mean, I've been to Kazakhstan and I've had Nazarbayev here. Part of the problem that they're not successful there is they haven't structured the markets. And the markets don't allow people to make profit, and they don't allow enterprise to work. So GMOs are fine, and non-GMOs are fine, but if you don't have the market structure to allow people to make a living, neither one of them work.
Can I comment on that?
Yes, you can, of course.
That is such a good point, because when I first started working in this field, I would say to farmers, what is your biggest problem? And very often it was drought and markets. And as long as you've got a market, then you've got a living. But it's quite interesting talking to the women farmers, the smallholder farmers from KZN. And the men say it's a huge problem that there isn't access to markets. The women say, no, it's not a big problem because we're just going to feed our families. So it's a different approach.
Next year's debate is going to be whether, without GM, it's possible to be a former politician. Thank you, Mr. Devine. Your turn.
So my name's Sarah Gurr. I hold the chair in food security at the University of Exeter, having spent the previous 20 years as a professor, well not 20, but as a professor in Oxford. And John Pickett charged me with coming up with a word for you, Rex, that you probably wouldn't use normally, which is, I wish to discombobulate the argument. So I wish to speak with a passion about why GM should be used. And I want to use a simple example, and that is of the potato. So the potato is probably going to be one of the most important foods throughout the world because it's not volatile on the international markets, but yet it suffers from two particular diseases. So we've been modeling the movement of pests and pathogens, and we can see that of the very serious challenges that are going to face us in a warming world, it's going to be particularly cyst nematodes and root knot nematodes on potatoes, and also of Phytophthora, so late blight on potatoes. And whilst we can conventionally breed for disease resistance, we can't breed very well for resistance to nematodes. So here there's a beautiful story which unfortunately, because of the moratorium on GM in the UK, stopped it ever coming to market. And that is a story where scientists were able to make genetically modified potatoes where they actually hooked up a switch which switched on a death cassette when the nematode went in to feed in the root. And this was a beautiful piece of work, but which I said never reached market. And what alternatives do we have to control nematodes? Well, we have incredibly toxic agrochemicals. Number one in the world is aldicarb, which was made previously by Union Carbide, the toxic precursor of which killed many people in the disaster in Bhopal. So what are we faced with? Toxic agrochemicals or GM, where we've got simple modification of a gene in a potato root, and we don't eat roots, we eat tubers, where you've got a timed switch which switches on a death cassette system to wipe out a nematode. It's a beautiful story, probably even more potent than golden rice. And yet it's something that's been hidden from the press in a way. because of the moratorium in the UK.
Do any of you wish to comment, please, Peter?
So, and I agree that it is a very nice story. It's a very nice science, but I'd also, my understanding is that there are actually resistance genes available in some of the wild germplasm, the relatives of potatoes. Potatoes is a difficult crop to breed as a tetraploid, and some of these wild relatives that have resistance are quite hard to cross into potatoes. But there is resistance. My understanding is there is resistance. Some of those wild relatives that could potentially be deployed if there was the investment in that science and that research, but there currently isn't.
So
Are you talking about nematode or late blight?
Both, actually. Well, late blight, there is actually now resistance that has been. So the same argument was made for late blight for a long period of time. The GM was the only solution to that. But now there are actually quite good resistance lines that have been found through some of the crosses with the wild relatives. And my understanding is that there is also now resistance that's been found for the nematodes.
may I answer that?
Yes, please.
So
Go right ahead.
particularly with respect to Phytophthora, the late blight pathogen, insight into the genome sequence of the late blight pathogen shows that this is an architecture full of plastic variability, meaning it's littered with polymorphisms, with effectors, and with retro DNA, which means that if you take a hectare of an infected potato field and you count up the numbers of spores, the zoospores there, you can have 10 to the power 11, 100,000 million spores with the plastic genome. It takes literally 12 weeks for natural evolution to fast forward selection to counter single dominant resistance genes. And whilst we can stack or pyramid resistance genes into our potatoes, as you can see, they can overcome very quickly. And in fact, if you look at conventional breeding of barley, for example, in a cultivar that was released called Klaxon, it took the powdery mildew pathogen 12 weeks to simultaneously overcome 3 resistance genes. So I think what I would shout for is very much pro-GM, but also for low-impact farming for agriculture and for the future, meaning that we need a far better integrated policy of looking at every single technology and deploying everything that we have to protect ourselves against disease throughout the world.
So our argument, as
Thank you very much.
Would you
as
like
I
to?
said, our argument has not been to say that GM should not be allowed. But again, the examples that Sarah used there have been effective resistance breeding strategies. If you pyramid, go from 1 gene to 2 genes, for each additional gene, you change the equation by 1 order of magnitude. So if you go to 3 genes, then it expands quite dramatically. And in fact, cases I know of where there have been where there have been 3 single dominant genes that have been deployed, the resistance has not been overcome. So there are strategies, they are more complex, but they can be done. It goes back to the theme of the debate. Is GM required or are there alternatives?
Okay.
And again, I haven't heard yet an example from either side to say that GM is the only option that we have.
Okay. Please.
Good afternoon. My name's Brian Tracy. I'm with Monsanto Canada. I'm one of those molecular biologists that needs to be rounded up, I think. I just wanted to comment. First of all, thanks to Morris and the panel for an excellent debate. It's been a lot of fun to listen to all the dialogue. But I just wanted to comment on Peter's argument. I.e., do we need GM biotechnology, or is there still room to improve on what we already have in place? And the comment that I want to make on that is I think the short story is we need it all. So is there room to improve on the genetics and the germplasm? We heard about cassava was earlier today. 5 breeders. Do we need more? Yes, we do. Is there room to enhance genetics across a whole bunch of crops around the world? Yes, we do. Do we need mutagenesis, which, by the way, was developed in the 1950s? And yes, there are 2,000 varieties on the FAO website. Do we need that? Yes, we do. Do we need biotechnology as another tool? Not a silver bullet, but as another tool? Yes, we do. Do we also need things that are coming down the pipe? Digital applications to agriculture, new breeding techniques. We heard about CRISPRs from Mark. Absolutely. It's time to move from the analog phone to the iPhone 6 or soon the iPhone 7. And I've had the opportunity to witness agriculture in Canada, the US, China, Europe, and I went to Africa for my first time a couple of months ago. And I would submit that there's a spectrum of where we are in this continuum of agriculture. Some people are working to enhance the analog phone, and other people are pushing the envelope trying to get to that iPhone 7. So the short answer, in my view, is we need it all. We live in a really difficult environment. It's getting worse through climate change. And for anyone who has had the backyard garden, it's biological warfare out there, and we need all the tools we can get. Thank you.
I'll get to the gentleman next, but first, if anyone on the panel wants to add anything, okay. Sir, you're next. Please go ahead.
It seems to me there's only two people that said anything that made any sense. Barbara was one. And the way she put together her announcement on being able to feed the individuals a nutritious diet. Is biotechnology putting nutrition in our foods? It's the processor. Vitamin D added, vitamin A added, vitamin C added. So do we need biotechnology to feed 9 billion? We can't feed 7. We need food distribution to the hungry. Whether it's biotechnology that puts it there or gets it growing, it's transportation to those that are hungry. The other one happened to be our ex-politician, said everybody's got to make money. Absolutely. But do the shareholders of Cargill, Patterson, Monsanto, Bayer, who contributed nothing to the production, are they the ones that are to be making money? Is that who we're talking about? Don't think so. It's the producer. And those that are in power of supplying the money to the producer, one of it would be Cargill, know the average production of land and what they think you need to make a living. Their standard of living is a whole lot better than mine as a producer, yet they produce nothing and take. When governments can figure out how to change their budget from a military budget to an agricultural budget, we'll feed 9 billion. If there isn't a disease that come along from Mother Nature, as it does in the wildlife, to kill us off first. Thank you.
Thank you. Is there any other at this point? We're getting close to calling on the teams to give their recapitulation, so one or two more probably is the limit. Go ahead.
Well, thanks so much for such an interesting, entertaining, and intelligent discussion. In the real world, however, discussions such as this goes differently. Mark mentioned how the Europeans, the parliamentarians, just basically said no to GM in Africa without reason or based on science. So our question is, as citizens, do we want policymakers to take decisions based on what? Ideological entrenchment, or simply no reason, or do we really want policymakers to do decision-making based on evidence and based on science? That's basically, I think that could have been the question for the panel, but again, I congratulate you for such a great job you have done today. Thank you.
This, in fact, relates to the last person who spoke. I mean, it really doesn't matter who wins this debate if the pro-GMO lobby loses the media war. It's really interesting to have heard that so many people lamenting the fact that these European politicians are preventing the movement of GMO products into Africa. I wonder why this is, why these politicians aren't being persuaded by true hard science, and why so many people are listening to the dissemination of these nonsenses. Perhaps Mark could comment on that. You know, it was interesting that I worked with a molecular biology company for a while, and they had a competition. They said the anti-GMO lobby calls our products Frankenfoods. Is there anything that we can come up with, any name that shows the positive aspects of these modified foods? And nobody could come up with a name which was catchy enough to make a difference. So it'd be interesting to hear your comments about how these impassioned molecular biologists, none of whom I would imagine storming the Bastille, but how they can get together to win the media battle, which obviously will be required to get these foods where they need to be.
Thank you very much. We've come, I think, to the end of the audience portions. I just have one question I'd probably put to do. We will go with the persons against the motion first. Okay, understood. We'll now call upon the debaters to return to, we'll take one from each side. There has been a range of variation of both issue and subdivision within an issue on this, and it's obviously a very energized kind of topic. So 5 to 7 minutes is the limitation on rebuttal, recapitulation, or just having hell up here. And Peter, you're doing that so very well. You're called up on first.
Well, I find myself in a somewhat difficult position. At this stage of the debate, I should be up here rebutting the arguments that have been made by the pro group. But quite frankly, I don't think I've actually really heard any. We've heard an impassioned defense of GM crops. We've heard an impassioned argument that farmers should be allowed to grow them, that they have significant benefits. We've been given examples that have shown how they've had a huge impact in some parts of the world. We've heard about their importance in tackling some of the major problems. But what's that got to do with the argument about whether GM crops are required for global food security and for feeding 9 billion people? We have not presented a case to say that somehow GM crops should be banned, that would stop all research on GM crops. We presented a case to argue that there are a whole range of technologies out there that need to be deployed, that should be deployed, that can achieve the same objective that many of the GM technologies are aimed towards, but that are focused very much on using existing resources, capabilities and technologies and ensuring that the pathways and delivery mechanisms are there. Even if we were to go to the scenario where we were to say that GM crops were required, I think you have to remember that there's a whole structure that needs to be put in place to see effective delivery of that technology. The example that we talked about before about our minimum till that Mark regarded as being a case for GM was actually a technology that was developed well before GM, and is an example where GM has been helpful, has helped with the deployment, has been a very useful tool, but has not been required for minimum till agriculture to be delivered. It's applied in many parts of the world, not as effectively as one would like, in the absence of GM technology. So there is a lot that we can do and we can achieve without having to go to the GM tool, the GM toolbox. Now, is there a problem with deploying GM? We don't believe there is. We're quite comfortable with GM to be used and to be one of the tools that are available to farmers and to growers. But part of the problem has been that GM has also had a negative effect on the way in which technology is delivered and developed. It's created a focus on the argument about whether GM crops should be allowed or not allowed. In fact, we've heard much of the debate today has been diverted onto that topic and that issue. We know that in many parts of the world there is very, very strong opposition to deploying the technology. We waste a lot of resources in going through arguing about it, looking at alternative technologies and strategies that are not quite GM and might be accepted. Is this a waste of resources? Could we be putting money into other activities and other strategies? Should we regard GM as a really important tool for understanding genes, understanding systems, and understanding processes, and then going back to a whole range of other technologies that can use that information then to provide the delivery and the outcomes that farmers need? Our argument has been very much to try and present to you a case that there are a broad spectrum of technologies that are out there that can be used. These are technologies that have been very successful in the past. We've seen the dramatic improvements that occurred in yields and in global food security as a result of the Green Revolution. That did not require GM. Can we see another phase of major gains in crop production and in the quality and sustainability of crop production systems? I think we can. I think the tools are out there. We've tried in this debate to give you examples of the technologies that can be deployed, that can be used. Should we be shifting our investment and our focus onto those technologies? Can we deal with the problems and the naivety that's come around the deployment of GM? Both sides have made a clear argument that GM is not a silver bullet, but it is being used and treated as a silver bullet by many people, both for and against the technology. And that in itself is a significant problem and one that we need to address. I hope that when you cast your vote, you will remember the question that you've been asked to comment on, which is GM and advanced technology required to feed 9 billion people? I hope that you will agree that we've made a strong case that it's not required. It is an addition, it would be helpful, I have no problems with it being deployed, but I do not believe it is absolutely required. I think there are other technologies, I think there are other areas we should be investing and considering, and I think in many respects the whole debate about GM has undermined a lot of the questions and issues that could have a far greater impact upon food security. So please vote against the motion.
And now we have the last speaker, and after this we will return to this business of voting and choice and deliver balm to one ego and bruises to another. Please, Mark, your turn.
Well, thank you very much. Once again, I respectfully disagree. We are not required to prove that GM is the only answer to any of the world's problems regarding food insecurity. We are merely required to show that GM is one of the most important tools, or is a tool in the box, that it should not be taken off the table. I'm glad you haven't actually made the argument that you were required to make to ask people to oppose this motion. You needed to show, and I'm sorry you weren't able to do that, that GM crops are somehow not going to feed the world and are not going to do the things they said they're going to do. You said that they were helpful and that they were an important component. Well, we agree, right? We've never made the silver bullet argument. The silver bullet argument only ever gets made, I think, from the anti-side. So no, I agree. We don't need GM crops for insect resistance. We can go back to using more chemical insecticide. We don't need GM for blight resistance in potatoes. You can just dump on a whole load more fungicide. We don't need GM for drought tolerance in maize and other crops. We can just use a whole load more water and drain the ecosystems from the rivers and so on. But on the other hand, if we want to have a more sustainable agricultural system, if we want to improve the productivity so that we can spare more land for nature and so that we can feed the growing world population, if we can begin to address the decline that there's been in productivity increases from the past, then we need to use this technology. We have to have all tools in the box. We have to make every single option available to farmers and available to scientists. So with that in mind, I would urge you very strongly to vote in favor of the motion. Thank you.
Well, that concludes the debate. Is there now going to be an online number here for people? It'll show up on the screen. While we're waiting for the number, I think it is very appropriate that the four participants here, who obviously have given both energy, thought, and travel into making this case, and thought making it an interesting argument for the case, that some show of appreciation for their effort should be given to them as such before we get to votes.
I think the whole GMO thing has become symbolic of a lot of people's concerns about the whole food system. I mean, people reel off lists of names of multinationals. You heard Monsanto, Cargill. I mean, the concerns about the corporate dominance of the food supply is not a GMO issue, but it's all become wrapped up together, and so the whole subject of GMO has become a kind of a lightning rod. And the motion in the Parliament, in the European Parliament, was proposed by the Green Party, and basically none of the MEPs dared to oppose it, because it's just become a kind of hegemonic view in Europe now that GMOs are bad and that organic is good and that kind of stuff. So there's a lot of work to be done.
So the debate is stalled, as you see it, okay?
And another whole thing about the multinationals is I've seen it over my time. I started working in genetically modified bacteria in 1974. I've been around for a long time in this field. And in genetically engineered bacteria, in the early days, you'd get lots of people from universities coming to conferences, and slowly, as it got more and more expensive on the regulatory side, it got fewer and fewer, and at last it was only the multinationals who could afford it. And I can see it in my own research. It's only the multinationals who can afford to do the work. Yeah. And therefore, the antis who say, oh, it's the multinationals controlling it, well, they're the only people who got the money to do the regulatory requirements.
Interesting. I was telling you when I began, and you may have thought it was a joke, that the only time we launched into territory that might be genetically modified was the business of 1987. We tried to grow the cucumbers and make ourselves the dominant cucumber power of the North Atlantic. And that was true. We spent $27 million, and when they did a survey, StatScan did a survey of Newfoundlanders, and man, woman, and child, and even babies with no teeth and such. And they found that the consumption of cucumbers in Newfoundland per capita per year was a quarter of one cucumber per year. And that was only under hamburgers, as a pickle. So then we went through this vast experiment. We harnessed all the power from the Upper Churchill that wasn't being used elsewhere to hydroponically startle the cucumber out of the granite underneath that was buried in. After 1 year and $27 million, they had, I think it was a basket about the size of a standard tomato basket that they brought to Whole Foods in Churchill Square. And no one bought them, but they're souvenirs for the collectors of very strange agronomy. We're back. The things you do. Post-event poll, biotechnology is necessary to feed 9 billion people. The studio audience has gone from 100 and a bit to 122 and a little bit more than a bit. And the online audience, oh my Lord, you suffered there, lads. The online audience, 4 was stratospheric at least 35.
Do you understand that?
And now it's down to a handful against small, not much on the undecided. So there we have it. You have an alteration of opinion to some degree. I just think, again, I made light of a few things. The organizers of this debate took on a fairly hot topic and found a format in which to elucidate it and make it also, I think, engaging to the audience. And finally, one more time, for the participants, thank them very much, and we'll see you later. You want Mike?
And I think mission was accomplished this afternoon. We had a very entertaining and civilized debate. There was a little bit of a shift from the undecided into the various categories. But most of all, I just want to say a big thank you now to Rex Murphy, who has shown his skills in Oxford-style debating and led us to a very successful afternoon. Thank you, Rex.